100 years ago in Germany, the planetarium was born. A magical, mysterious invention to recreate the night sky. From the phases of the moon to the constellations, it could display anything in the night sky. People were truly amazed by the spectacle. It was a crowning achievement of human technology, a universe in a room. Now, we will tell you its story. The director of Germany's first science museum, Oskar von Miller, first conceived of the idea to build a planetarium. At the turn of the 20th century, as science began to transform the lives of humanity, von Miller established a new type of museum with a dream to exhibit science and technology in the same way that other museums display works of art. Von Miller also loved astronomy. He really wanted to display the whole night sky as a physical model to simulate the dynamics of the universe for explaining astronomical knowledge. He sensed that key concepts about the universe, the learnings from centuries of observation and thought, seemed only accessible to experts. But now, let's introduce the historical development of mechanical models of the universe. Generally, there were two types. One type was a spherical map of the stars, a celestial globe. The other was a mechanical representation of the motions of the sun, moon, and planets, called an orrery. Among ancient celestial globes, this one is the most famous. Atlas, the Greek mythological titan, is carrying a globe on his shoulders, showing the constellations that were recognized at the time. The academic tradition of ancient Greek astronomy was carried on by the Islamic world. Many of our modern names for stars are derived from Arabic words. Before the invention of optical telescopes, the most accurate observational measurements of celestial objects were made by the astronomer Tycho Brahe. This was his celestial globe. Now, what about the history of orreries, which could model the motions of the sun and planets? Here is the oldest known model that exists. In 1901, in the Aegean Sea, close to Antikythera Island, the wreck of an ancient Greek ship was salvaged, and a strange bronze artifact was found. After more than 100 years of careful investigation, what did they uncover? It was a mechanical computer containing over 30 gears to accurately simulate the motions of the sun, the moon, and the planets. The mechanism has the Earth at the center, with the sun, moon, and planets revolving around. In other words, it has a geocentric view. But after more than 1,500 years, the geocentric view was overturned. A new theory showed that the Earth must revolve around the sun with the other planets. It was a revolutionary idea. As the new heliocentric theory gained acceptance, many orreries were designed, with the sun at the center. Oskar von Miller, founder of the Deutsche Museum in Germany, the world's first science museum, had a new idea concerning the two types of mechanical models. Recalling that a celestial globe displays the stars in the sky on the surface of a globe, and an orrery is a model to simulate the motions of the sun and the planets. Von Miller imagined, what if we could sit inside of a celestial globe and look up at the model just as we see the starry night sky? At the same time, we could simulate the dynamic motions of the solar system. Could we make such an invention to combine the best features of celestial globes and orreries? In fact, there was a historical example of a celestial globe that could be viewed from the inside. This is a giant globe that was constructed in 17th century Germany. It's called the Globe of Gottorf. It really does allow one to see the model as if looking up at the night sky. The 17th century writer Eberhard Happel visited the globe and reported, 11 people can fit inside. It is greatly satisfying to sit at the table and see all of the stars illustrated in their movements. In addition, there was a giant-sized orrery to accurately view the motions of the planets. In the Netherlands, in the northern town of Franeker, is the Royal Ise Isinga Planetarium. Ise Isinger, an amateur astronomer, turned the ceiling of his house into a large-scale model orrery. The mechanism moves slowly, so it may be hard to notice. We will speed it up a little. It is the world's oldest working orrery that accurately tracks the true motions of the solar system. The Deutsche Museum wanted to make a celestial globe large enough for people to enter and which could also show the dynamic motions of the universe like an orrery. Von Miller decided to ask for help from the Carl Zeiss Company, based in Jena in Germany, who were specialists in optical instruments. The Zeiss Company conceived of a revolutionary idea. So, you want to simulate the night sky? We can make a large theater with a dome like a celestial globe. Then, in the center, we can construct an optical orrery that projects the sun, moon, and planets onto the dome. Not only that, if we also project the stars, it will be like a complete night sky. At that very moment, the idea of the projection planetarium was born. Von Miller was very excited, and he quickly started a project to begin working on it. But just as the planning got underway, the First World War broke out. The war lasted 4 long years, and Germany ended up the loser. After that, the planetarium development finally started, but it was not an easy journey. The mechanism for projecting stars proved especially challenging. The management at Zeiss even considered sending a letter to admit defeat. However, the engineers kept working, and they hatched new ideas to overcome the difficulties. They took a hint from the film industry for projecting celestial stars instead of movie stars. Movies require only a single lens for projecting light onto a flat screen. However, a hemisphere-shaped dome would require multiple lenses for projecting in every direction, all from one central source. The engineers needed a way to project light accurately anywhere on the dome. Calculations began to find a suitable design. Original development notes are still available in the archives of the Carl Zeiss Company. We can examine the notes and design drawings to better understand the journey to the birth of the planetarium. To project stars in all directions onto a dome, we need a base that is nearly spherical on which to mount multiple lenses. The engineers first made a 20-sided polygon to project light from each of these 20 faces. Then they made further improvements to approximate a spherical shape. By cutting the corners off, they could transform the 20-sided polygon into one with 32 sides, like a soccer ball. On each surface, a projection lens is mounted. That's good enough to project the stars anywhere on a dome. Now, we can use the projected light to replicate the starry sky. This star map of the sky is divided into 32 sections. Each lens is allocated to a section of stars, and working together, they should be able to display the entire night sky. Next, let's take a look inside the projection lens mechanism. Each lens is paired with a perforated plate with pinholes representing each star. The light passes through the holes to project the stars. Thus, the so-called star ball at the core of the planetarium was born. One more ingenious innovation can be seen on this technical drawing. A way was needed to simulate the motions of the planets in the solar system as seen from Earth. For example, let's observe Mars. Mars orbits the Sun 1.8 times slower than Earth does. Seen from Earth, the path of Mars appears to reverse course at times, which happens whenever Earth overtakes Mars in its shorter orbit period. The orbits of Earth and Mars are represented by two rotating gears connected to the projector by a sliding rod. When projected onto the dome, the motion of Mars will appear to draw a loop unexpectedly, hence the name planet, which in Latin means wanderer. In this way, the precise motions of all the planets in the sky is simulated by different combinations of mechanical gears. By the time the planetarium prototype was complete, there were over 600 pages of design notes and calculations. But the final product was even more wonderful than anyone had imagined. On the roof of the Carl Zeiss Company building, a large planetarium dome, 16 meters in diameter, was constructed. Since Oskar von Miller first conceived of his universe in a room, over 20 years had passed. Finally, it was ready to be shown off. When the chief engineer saw it, he made the following comments. I was involved with the Planetarium project for many years, so I thought I knew what we would expect to see when the device was turned on. But when I saw the actual projected sky, I was totally amazed. Now, we will explain the key functions of this first planetarium system. Diurnal motion, simulating the apparent motion of the stars as the Earth rotates. The speed of rotation is also variable. Annual motion. Using the planetary projectors, the motions of objects in the solar system as seen from Earth can be simulated. Latitude control. The first planetarium at the Deutsche Museum in Munich was designed to show the night sky fixed at Munich's latitude of 48 degrees north. This was later improved to show the sky from any place on Earth. The star ball was divided into north and south hemispheres, with planetary projectors placed between them. Then, the system was mounted on rotating axis. Once they could show the night sky from any place on Earth, many new planetariums were built, and they quickly spread around the globe. Along with early adopters in America, Italy, the Soviet Union, Austria, Belgium, Holland, and Sweden, Japan installed the very first planetarium in the Far East. In 1937, at Japan's Osaka City Electric Science Museum, an 18-meter planetarium dome was constructed, the Sky Museum. Although Osaka City was heavily bombed during World War II, the planetarium miraculously survived. After the war, the renamed Star Theater continued to be a popular attraction. The slanting sun appears as a white baseball across the sky, gradually moving west, then approaching the horizon, dipping below the skyline mountains. Sunset. In the twilight sky, one bright star appears. We can no longer see each other's faces. Dusk. Faint magnitude 5 stars and dust-like magnitude 6 stars appear. The pitch-black sky of night is all around. There! I found the Big Dipper, someone says. And that's the pole star. Oh, I see a shooting star. It's as if we are lying in a field, gazing up at the night sky. Thousands of stars form marvelous constellations. The stars seem to whisper among themselves, looking down at us. It's a magical invention for representing the starry sky. It can render the night sky from any viewpoint on Earth, even the Southern Cross as seen from the South Pole. Tracing the path of the sun along the ecliptic belt, the passing of days and months are described. When the moon waxes and wanes, flying through constellations, some in the audience even laugh out loud. these motions that we expect to take many months can be viewed all at once in a planetarium. Here is Mars, seen from the Earth. Using a combination of gear wheels, its precise motions are depicted forward and backward around the stars. A giant comet appears, stirring fear and surprise. Shooting stars cascade almost like a rain shower. Whether for telling mythological stories or for explaining new astronomical discoveries, it's like a star theater for voyaging through the cosmos. Before you know it, the sounds of bells ring out and the dawn breaks. All the bright stars fall away like flower petals, and only the light of Venus, the morning star, remains visible. The sun has risen from the eastern sky. The audience members, watching breathlessly, seemed to forget that they were sitting under the dome. Some people felt overwhelmed with joy and applauded continuously. After World War II, the starlight from the planetarium provided calm and consolation to the hearts of the war-torn public as they rebuilt their countries. As humanity has continued to inquire, what is the nature of our universe? Various mechanical models were developed. From these seeds, the planetarium was born. Here, every day has a clear sky full of stars. The greatest purpose of a planetarium is how it enables us to share this moment with others. Yet also, flying through the cosmos in our own personal spaceship, we may reflect on the miracle of life on Earth, or see our own lives from a new perspective. And that is the story of how we came to look up into the vast universe together.